Good morning, everyone. This video is about a blockbuster deal in baseball. Around the contract value is around $500 million. It's a big deal, and it's considered to be one of the biggest deals ever. And what happened was Padres, the baseball team, they acquired one of the top players named Juan Soto. And Padres got Juan Soto, but they gave away 4 players. Basically, they got 2 players, Juan Soto and Josh Bell, but they gave away all these players, 1, 2, 3, 4, 5, 6 players. Out of that, 4 players are considered to be good ones. And so is that a good deal? I mean, you get one good player, Juan Soto, but they gave away 4 players. Now, how to analyze this? So I was listening to so some of the comments here. There was one commentator named Alden Gonzalez. Imagine Mike Trout getting traded in the middle of the 2015 season, or Ken Griffey Jr. in 1993, or Ricky Henderson in 1982, Willie Mays in 1954, or Babe Ruth in So this is a deal that could be in the range, in the importance of Willie Mays or Babe Ruth. I don't know about Babe Ruth, but definitely Willie Mays, Ricky Henderson type noise is happening here. So Juan Soto, they're getting a very, very good player, and he's young. He's 23 years old, so there's a future. So they're getting this big, huge player, and then they're giving away 1, 2, 3, 4, 5, 6. But I was told only 4 players are in the can play in the major leagues. The other 2 are just startups in prospects. So these 4 players they're giving away. Padres going to get Juan Soto and another player, Josh Bell, and they're giving away 4 players. Out of the 6, only 4 are capable of playing in the major leagues. So they're getting Juan Soto. Let's assume Juan Soto, and let's keep Josh Bell for the side. So they're getting Juan Soto, there's a top player, and giving away 4 players. So how to analyze this? How to mathematically model? And some say, well, they're getting 1 player, but they're losing 4 players. That doesn't really say anything. But then they say, yes, they're getting Juan Soto. They had a player here. They had a player that Juan Soto is going to replace. Let's call that player A. That player A has to have a lesser average than Juan Soto, because otherwise they would not bring in Juan Soto. Why would they bring in they were trying to improve. That's why they give all these players out and get 1 player that's going to. So player A that they have has to be lesser average than Juan Soto. So there's a difference in average. They're improving their average. Now on the other hand, they're giving away 4 players. We're considering 4 because only 4 are ready to play major leagues, and they're giving away 4 players who are playing right now, and they're replacements. Now once you give away a player, let's say Louis Voit, they give away Louis Voit. I'm talking Padres. Padres got Juan Soto, and then say they give away Louis Voit, and then Louis Voit has to be replaced with a player, and obviously has to be a lesser player than Louis Voit. Otherwise, the Padres would not receive. If they had a better player, the Padres would ask for him. So the replacement has to be slightly less than Louis Voit. So here's improvement, and there's I don't know, whatever the opposite of improvement, degradation of the average due to these 4 players. So how to calculate that? So there's a mean and a standard deviation for Juan Soto, and there's a mean. So we are going to do Monte Carlo analysis, not geometric Brownian motion. So there's a mean and a standard deviation. So we can model that. We can model like this. So how are we going to model this? So We are going to have regular normal distribution. We are not going to use geometric Brownian motion or anything else. Standard Monte Carlo normal distribution. So see what's going to happen. So we are going to find the difference between one Soto and the player A. Now I have hypothetical numbers. I don't have the real numbers, but for our purpose, we are just trying to develop a methodology for to model the Monte Carlo, using the Monte Carlo method to model this. So the D1 is 0.38 is Soto's average. It's not Soto's average, it's just hypothetical that I assume. And minus 0.3 is the player A that Soto will be replacing and his average. So what you're getting is 0.08. That's the difference. So in other words, batting average at that position where Soto plays will improve by 0.08. Now these are hypothetical numbers. I don't have time to go around looking for their real averages. It's not necessary for our purpose. We are just trying to mathematically model. So we are going to get the difference, the Soto's average minus the average of the player that Soto will be replacing, and his average has to be less. Otherwise, why would they bring in Soto? And then you could normally distribute this. You could use Python, but you could use Excel. So norm inverse, you get a random number, and that random number would be within this mean and standard deviation. And the mean and standard deviation of Soto is known. He played in the past. We have his mean and we have his standard deviation. And then we have the mean and the standard deviation of the player that he's going to replace. So now we could find the difference. So I have Excel sheet here. Let's see here. So okay, here we go. So Soto. So if you go here, norm in ran, I just have Soto's average as 0.3 and his standard deviation as 0.05. And then the player A has to be less, 0.2 and 0.04. These are hypothetical numbers that I just put it in. So the improvement is this minus this. So this would be the B10 minus 10. So now we could, with this random number, now if you could see here, we can type anything and now everything would be changed. Now here you could see the chart. The blue is Soto's average, and the orange is the player A's average, and yellow is the difference. Okay, let's see whether I could yeah, so blue is Soto's average, orange is player A that he's replacing, and the yellow is the improvement. Okay, so we can model this, we can change this, let's say every time, so we can get distributions, any amount of distribution. It keeps changing because these are random numbers, but it's always looks to me like there is some improvement because Soto is a better player. Now we can do this for all the other players. So let's call these players so let's say X1, X1, X2, X3, X4 are the players that they send out to nationals. So the Padres send out 4 players. Now out of 6, we take only 4 because other 2 were not major league ready. So I have these hypothetical numbers: batting average X1 0.18 with a standard deviation 0.03, X2 1.5 with standard deviation 0.01, etc. And then the Y1, Y2, Y3, Y4 are their replacements. So these people are going away and they used to play, and their replacement has to be lesser, because if these guys were better than these guys would be playing in the team, in the lineup, but they were not. So they have to be slightly less. Now there could be other reasons, the discipline and the fielding, and fielding is a big thing. Shortstops are there, first baseman, but we are not considering all that for our modeling purpose. So we are just assuming that the players who went were better players than the players that they're going to replace. So I have these hypothetical numbers here. So x1, x2, x3. So let's look at x1. X1, I'm trying to, so x1 is norm in random number, and his average is 0.18 and 0.03 is mean, standard deviation. Now x2, I just have his average 0.15 and a standard deviation of 0.01. So the function is norm in random number that's going to be generated with mean of 0.15 and a standard deviation of 0.01. So x3 is mean of 0.12, standard deviation of 0.01, x is 0.1302, etc., etc. So this is the function that you can use to generate random numbers. So now every time you click a cell, you could get a different distribution. Okay, so let's say, see it's keep changing. Okay, so y1, y2, y3, y4 are basically the replacements, and the difference is the total average that they had, x1 plus x2 plus x3 plus x4 minus, now the replacements are going to bring in some averages that they, and that will be minus y1, y2, y3, y4. So that would be the loss, that would be the loss that they have. And then we have improvement due to bringing in Soto. So we have a loss here, sending out 4 players, and improvement due to bringing in Soto. So difference between the improvement due to Soto and the loss is what we are looking at. And this one, I have a chart here, and this is the final analysis. Now these are all hypothetical numbers. These are not real numbers. Okay, so some years this minus mean bringing in Soto is not good, and then some years it's plus. That means there is improvement. Bringing in Soto is good. Some years it's not good. Some years it's really good. Some years, and some years. Now this chart would tell you when it is good, how good it is. It's very good, or so this is the chart that we can have using. So let's go through here. So this chart here. This is the Soto's. Now we can change this. Okay, every time we click a cell, see, it changes. So this is the Soto's average. This is the replacement player's average, and this is the improvement. And then the blue is Soto's average. Orange is the player that he replaced, and yellow is the difference. So we could have this, and here this is only the improvement alone due to bringing in Soto. And now we have a loss, as I said, bringing in sending out these 4 players. So we have a difference and improvement due to Soto, and then we could find the total difference. And now, so this is the final number. So this can be changed. Okay, so as you could see, every time we click a cell, all the numbers going to change. Now let's see here. Now in this case, in this run, you would have a good year, 0.5 average improvement, but there's a big drop, minus 0.18 drop in the averages, and then 0.2 improvement, and a big drop again. So what I see is that relying on one player, he would bring in a lot of average, a lot of batting average into the team, or lose a lot. These are hypothetical numbers. These are not real numbers that I used. So this is the modeling part, and I hope you understand what I did. Thanks.